Welcome to the Deep Dive. We dig into your sources to pull out the key insights. And today, wow, we have really electrifying topic, literally from the late 19th century. The War of the Currents. Just picture America, right? Bubbling with energy, second industrial revolution, everything's on the verge of changing thanks to electricity. And this wasn't just, flipping a switch for a light bulb. It was about unlocking massive national productivity, incredible wealth. At the center of it all, these two huge figures. Thomas Alva Edison, everyone knew him, the Wizard of Menlo Park, championing direct current, or DC. That's where electricity flows steady, just one direction. Think water in a hose. And then there's for a long time, the more mysterious Nikola Tesla, a Serbian-American immigrant, a visionary with these radical ideas about alternating current AC. With AC, the flow reverses constantly back and forth like a wave. Very different. So this deep dive, it's more than just tech rivalry or some personal spat. It's fundamental. This battle basically laid the groundwork for, everything modern infrastructure-wise. Our mission today is to unpack how Tesla's AC system winning out, backed, crucially, by the industrialist George Westinghouse, how that victory didn't just end the war, but really became the key accelerant for the U.S. becoming a global economic giant in the 20th century. Okay, let's get into it.
Yeah, and what's so fascinating, I think, is how much the personal stories, the personalities of these two men really drove this huge technological shift.
Absolutely. The human element is huge here. So should we start with Tesla? Maybe the lesser-known figure, at least back then.
Good idea. Nikola Tesla, born 1856, Austrian Empire, was now Croatia. And right from the start, he was, extraordinary, intellectually gifted. He had this photographic memory they talk about, could recall whole books, complex diagrams, just like that. And even more striking was his visualization ability. He could design, build, test perfect, incredibly complex machines entirely in his head before touching a single tool. There's this story, maybe apocryphal, maybe not, from when he was a kid. Fixed a town fire pump that was malfunctioning. The adults were stumped, but he apparently saw a kink in the underwater hose just by observing. Shows that innate problem-solving knack he had.
That's incredible, designing it all in his head first. And he studied engineering physics in the 1870s, though never actually got a formal degree.
Right, no formal degree. But his time in Europe, studying, even just auditing lectures in places like Prague, it gave him this deep theoretical foundation. Especially understanding things like the rotating magnetic field. That concept was absolutely key for his AC induction motor. And this was just fundamentally different from the American way of inventing back then, which was much more trial and error. Tinker until you get something marketable. Tesla's thinking was more top-down. Start with the theory, design the whole system, generation, transmission, use all integrated. It let him see these breakthroughs years ahead, but it also maybe made him less suited for that immediate profit-first American industrial scene. And that was a weakness Edison definitely exploited later.
So fast forward to 1884. This genius arrives in New York, almost broke, just a few cents, right? And a letter of introduction to Thomas Edison. It really does sound like old world theory meeting the rough and tumble American industrial frontier.
Exactly. And, the first meeting, it actually sounded quite promising.
Two giants, but coming from such different places mentally. What was that dynamic like initially at Edison Machine Works?
Well, at first, Tesla was genuinely impressed by Edison's success. And Edison, he wasn't blind. He saw Tesla's brilliance pretty quickly. He actually gave Tesla some of the company's really tough engineering nuts to crack. But their styles were just poles apart. Edison, master of experimentation, thousands of trials, that 1% inspiration, 99% perspiration philosophy. Tesla could nail the invention in his mind first, then build it. That fundamental difference, it just created this constant underlying friction between them.
Okay, and here's where it gets really juicy, right? The breaking point. This infamous story about American humor and the $50,000 promise. What actually happened there?
Right. So Edison throws down this challenge to Tesla. Says if he can redesign the company's DC dynamos, these early generators, which were pretty inefficient, that Tesla can make them significantly better, Edison will pay him this huge sum. $50,000. It's like, over $1 million today? Massive incentive. So Tesla, he dives in, works like crazy for months, doesn't just tweak things, he fundamentally redesigns the whole system. Huge boost in efficiency, huge commercial value added. He goes back to Edison, task completed, asks for the payment. And Edison, he just laughs. Famously says something like, Tesla, you don't understand our American humor.
Wow, just dismisses it as a joke.
Pretty much. And this wasn't just reneging on a bonus. For Tesla, it was a deep professional ethical betrayal. Shattered any respect he had left for Edison. He resigned not long after. And that incident, it really turned their technical disagreements into something much more personal, much more bitter. It really highlights that clash. Gilded Age capitalism business tactics over promises versus Tesla's maybe more idealistic view of scientific honor.
Okay, so the gloves are off. The stage is set for this war of the currents. What was the absolute core technical, maybe even philosophical difference driving this fight between DC and AC?
The absolute root was their totally different visions for electricity's future. Edison had built his entire empire, patents, factories, power stations on direct current. His money, his reputation, it was all tied up in DC. And his system, look, it worked okay for dense cities where power plants could be close to the customers. But the killer limitation was distance. DC just lost way too much power after, say, a mile or maybe even less, maybe just a kilometer or two. You couldn't send it far.
So it was geographically locked in a way. What did Tesla see that Edison didn't or maybe wouldn't see?
Tesla saw the real future needed power sent over vast distances. Think harnessing power from huge remote sources like Niagara Falls and sending it to cities hundreds of miles away. And his alternating current system was the key, because with AC, you could use these things called transformers. Simple devices, really. They could step up the voltage incredibly high for efficient long-distance travel with minimal power loss and then step it down again at the other end to safe, usable levels for homes and factories. AC was the only way to do that on a national continent-wide scale. So it wasn't just which current is technically better. It was a fundamental fight over two models for civilization. Edison's localized power islands versus Tesla's vision of an interconnected national grid.
That makes sense. But Tesla, even with this brilliant vision, he needed muscle, right? Financial backing to actually challenge Edison's established dominance. Who came into the picture then?
Right. After leaving Edison, things were tough for Tesla. There are stories of him literally digging ditches for $2 a day just to survive. But his patents, especially for the polyphase AC system, which is basically a way to create a smoother, more powerful rotating magnetic field for motors, they caught the eye of George Westinghouse. Westinghouse was another major player. An inventor himself, made his fortune with railroad air brakes. He understood complex systems, and he immediately got the potential of Tesla's AC. He saw it could smash DC's distance barrier. So Westinghouse bought Tesla's patents, hired him as a consultant. That gave Tesla the crucial financial backing, the industrial manufacturing power he needed to actually take on Edison. And that partnership, that's what turned it from a personal feud into this huge industrial war. Edison backed by J.P. Morgan versus Tesla backed by Westinghouse.
Okay, so the battle lines are drawn. And Edison, realizing his DC monopoly was seriously threatened, he didn't just compete on technical merits, did he? He launched this pretty shocking PR campaign, a fear campaign, really.
Oh, absolutely. It got nasty. Edison started spreading misinformation, publishing pamphlets, lobbying politicians, all trying to paint AC as inherently deadly and dangerous. And then it got really dark. Edison and his associates, like this guy Harold P. Brown, they staged these horrible public demonstrations. They gather stray dogs, cats, sometimes even larger animals like horses, and electrocute them using AC power right in front of crowds just to drum up fear, to prove AC was the killing current, and probably the grimmest part. Edison, who'd actually opposed capital punishment before, he secretly advised New York state officials to use AC for their new execution method, the electric chair.
No way, seriously?
Yes. His goal was to permanently associate alternating current with electrocution in the public mind. Just a ruthless, cold-blooded marketing tactic to destroy the competition.
That's chilling. Okay, to help our listeners really grasp the core differences here, let's maybe break down the technical and commercial pros and cons of AC versus DC back around, say, 1890. What were the key distinctions?
Okay, connecting it back to that big picture, AC's practical advantages were just huge, really. Transmission efficiency. DC was terrible beyond a mile or so. Massive energy loss. AC, excellent. High voltage meant it could travel hundreds of miles efficiently. That's the key to a national grid. Voltage conversion. DC was hard. Needed these bulky, inefficient motor generator sets. AC, easy. Use simple, static transformers, no moving parts. Very efficient. Like we said, the step-down capability was crucial. Infrastructure cost. DC needed tons of small local power plants, maybe one every square mile or so, hugely expensive. AC, you could build a few large central power stations. Much, much cheaper infrastructure overall. Safety. Well, DC was perceived as safer, maybe because it was constant, but high current of any type is dangerous. AC got attacked as lethal, but really, with proper insulation and using transformers to lower the voltage for end use, it could be made perfectly safe. And the core tech. DC relied on generators with these complex sparking things called commutators to keep the current direct. AC used simpler alternators, and critically, Tesla's AC induction motor, super efficient, reliable, no commutator needed, perfect for industry.
Okay, the technical edge seems clearly with AC then. But public perception, especially after Edison's campaign, that's powerful stuff. So where did the definitive showdown happen? The moment that really proved AC's case to the world?
That moment really came at the 1893 World's Columbian Exposition in Chicago, the Chicago World's Fair. This was absolutely critical. General Electric, which was Edison's company, after some mergers, they put in a bid to light the entire fair using DC. Their bid was $554,000.
Yeah.
And Westinghouse came in using Tesla's AC system, and they dramatically undercut GE, bidding just $399,000, and they won the contract.
Huge win, and the result was visually stunning, wasn't it? The White City.
Oh, spectacular. When President Grover Cleveland flipped the switch, something like 100,000 incandescent light bulbs, all powered by Tesla's AC system, generated by Westinghouse alternators, they all lit up simultaneously, illuminating the entire fairgrounds. For the millions of people who visited, maybe 27 million people, this was likely their first time seeing electricity used on such a massive, brilliant scale. It was just undeniable proof of AC's power, its capability, and importantly, its safety when properly handled. It was a massive PR victory for AC. It basically settled the debate in the public's mind.
A huge public demonstration. But the ultimate technical proof, the real nail in DC's coffin for widespread use, that came with harnessing Niagara Falls, right? One of the era's biggest engineering challenges.
Absolutely.
Yeah.
Niagara Falls was the ultimate test case. The dream was to tap into that immense natural power and send it to Buffalo, New York, which was a growing industrial center about, 26 miles away? Around 42 kilometers. Now, over that kind of distance, Edison's DC, just forget it. The power loss would have made it completely impractical. The commission set up for the Niagara project, they studied everything available worldwide, and they concluded only Tesla's polyphase AC system could actually do the job. Westinghouse got the contract.
And the big day was November 16th, 1896.
That's the date. They threw the switch, and power generated by the hydroelectric turbines at Niagara Falls flowed through transmission lines and successfully lit up industries and streets in Buffalo. That event basically marked the unofficial end of the War of the Currents. It proved definitively that AC wasn't just another option. It was a way forward for powering a modern industrial nation. And you see, AC's victory wasn't just about a better product, it was the victory of a better system. Edison's DC was sort of a closed loop designed to sell his specific bulbs, his meters. But Tesla and Westinghouse offered an open, flexible platform, generation, long-distance transmission, efficient motors. It could power anything, anywhere. The Chicago Fair, Niagara Falls, they weren't just wins for AC, they showed a whole new, scalable way to organize energy in society. Exactly what the Second Industrial Revolution needed to truly take off.
So AC wins the war, becomes the standard. But what about the legacies? What happened to the companies and more personally to Edison and Tesla themselves after this?
Well, financially, the big winners were the corporations. Ironically, Edison's own company, General Electric, after all those mergers. Well, market reality forced them. They had to abandon Edison's die-hard DC stance and invest heavily in AC technology just to survive and compete with Westinghouse. It's kind of an amazing twist, isn't it? Edison's corporate legacy, GE, ultimately thrived because it adopted the very technology its founder fought tooth and nail to destroy.
That is ironic. And the men themselves, Edison and Tesla, their paths really diverged, didn't they?
Dramatically. Edison, even though he lost the current war, he was brilliant at cultivating his public image. He remained America's greatest inventor, stayed wealthy, hugely respected, famous right up until his death. His name basically became shorthand for American ingenuity. Tesla, though, the man who literally gave us the modern electrical system. He kind of faded from public view. He poured his energy into even more ambitious, often fantastical projects like transmitting power wirelessly around the globe. But funding dried up. His later years were spent in relative isolation, living in New York hotels, often struggling to pay the bills. Apparently, pigeons were his main companions. He died in 1943, almost broke. And interestingly, the U.S. government immediately seized all his papers and belongings after his death. Shows they knew how important and maybe mysterious his later work might have been.
It really does say something about perhaps American culture at the time, doesn't it? The ability to commercialize, to market, to profit from an idea often seemed to overshadow the brilliance of the idea itself. Edison was the master businessman, the marketer. Tesla was the pure visionary, maybe less concerned with the money side. And he paid a price for that, becoming sort of an unhonored prophet. So did Edison ever, publicly admit he was wrong, ever give Tesla credit?
No, there's no record of Edison ever publicly praising Tesla or conceding that AC was superior after the war ended. But as we said, his actions, or rather his company's actions in embracing AC, spoke louder than words. It was a silent admission, forced by the market. His public silence probably just reflects his personality, intensely competitive, incredibly proud. He lost the technical fight, but he wasn't going to say it out loud.
Okay, but here's where it gets really interesting today, a kind of modern twist. Is it possible Edison is getting a sort of final revenge? Is DC making a comeback?
It's a fascinating epilogue, yes. The story isn't quite over. While AC is absolutely still the standard for the big power grid, transmitting power over long distances, the explosion of digital electronics, things like computers, smartphones, LED lighting, plus renewable sources like solar panels and massive data centers, all this stuff has created a huge new demand for direct current. Think about it. Almost all your modern gadgets run internally on DC. They need those annoying power breaks, those adapters, to convert the AC from your wall socket back into DC, and that conversion wastes energy. Same with solar panels. They generate DC electricity naturally. Right now, we usually convert it to AC to feed into the grid, and then maybe convert it back to DC inside our homes to power our devices. It's inefficient.
Right, all those conversions lose energy. So what does this mean for the future? Are we heading back to DC?
Probably not an either-or situation. The likely future isn't just AC or just DC, but a kind of hybrid system. You'd still use high-voltage AC for efficient, long-distance transmission across the country, the backbone of the grid, but then you might see more localized DC microgrids, maybe within buildings, neighborhoods, or data centers. These could power our increasingly digital world much more efficiently, directly using DC power where it's generated or needed. So yeah, in a really surprising historical reversal, Edison's original vision of localized DC power is kind of being resurrected, not to replace AC, but maybe to work alongside it as its necessary partner for the digital age. And that definitely makes you wonder, how is this evolving hybrid energy landscape going to reshape our cities, our industries in the decades ahead?
So wrapping up our deep dive here, the main takeaway seems clear. The victory of alternating current in that fierce war of the currents was arguably the single most important technological boost that launched the United States into its role as a global superpower.
Absolutely, establishing that reliable, long-distance AC power grid, which really came out of this bitter fight between these two geniuses, fueled by industrial ambition that became the bedrock for America's second industrial revolution. It just unleashed incredible productive power. Factories weren't tied to rivers or local DC plants anymore. Cities could grow exponentially. It forged a truly unified national economy, cheap, plentiful AC power. That became the absolute lifeblood of America's industrial strength, its military might, all through the 20th century.
And the legacies of Tesla and Edison themselves remain so tangled, so complex. It wasn't a simple story of good guy versus bad guy, was it? It was a deeply human, drama, ambition, genius, betrayal, huge visions clashing. But that very conflict, that intensity, it actually accelerated the future, didn't it? It forced the development and adoption of the electrical foundation our modern world is built on.
Exactly. And it leaves you, the listener, with a thought, perhaps. How much is technological progress always tied up with this kind of human drama, these unpredictable twists and turns? Think about the tech wars happening right now, and maybe arguments over AI standards or battles in quantum computing. How might the personal ambitions, the conflicts, the unexpected outcomes of today's innovators be shaping our future in ways we can't even fully grasp yet?